Hello and welcome. I'm Bill Wake. We're working on a basic interpreter written in Swift. We've done almost all the language by now, at least the level we're going to do. And we're working on the data read and restore statements. We basically got the data statement done yesterday, the day before, mostly yesterday. And we've got progress on the read statement, a little bit more work to do there. And then the restore statement should be very simple. So we'll hopefully have time for that today too. All right. So just a reminder, in BASIC, the data statements let you define constant data that you can like set up parameters and things like that. So you have data statements. They can occur anywhere in the program. The only thing is we read them in new order. So the 1, 2, 3, 4, then hello you, Bing, Don, Aaron, those all have to come in order. So line 40 reads the first two numbers, 50 reads the next two, 60 reads the next two strings, 70 reads 3 of the 4 strings. Now, if you tried to do a 75 read X, treating a string as an int, that should fail. Excuse me. And if you tried to read too much, that should terminate the program because you're out of data. And then finally, if you do a restore, you're basically saying reset back to the first data elements. And read mn would get 1, 2 again. Excuse me. I'll get it done. All right. So we've done the case, the line 20 data of reading strings that we've got. Sorry, actually, we don't have the string version done with the quoted strings. We've got the stuff in line 30, unquoted strings. They're comma separated and they get converted to uppercase. That's done. We've started the numbers like 1, 2, 3, 4, and we handle the case if the number is valid. But if you try and read like line 75 there, it's going to fail because it's not a valid number. We don't handle that error properly. We need to report basically throw an exception. And we left off with a test, a failing test. Let's see if I remember where it is. Well, it must be here. Read a number fails. So we expect if we say 10 read X and the data is a string, let's see, hey, Rick, nice to see you. So we try to read a number variable, but the data is a string, we should get some sort of error. Actually, I think I'm going to start moving towards these question marks. It seems to be a kind of common thing for these basics, okay? But right now, we just throw an exception. We try and force unwrap, and that's clearly not going to be a good thing. Let's see, where is that? 773. Oh, it's getting massive too. Okay, so yeah, basically we said try and turn this into a float. I guarantee, with this exclamation point, I guarantee it's going to work. Okay, well, that's not really going to work. Okay, so what we can do is, well, we can let float value equal float of raw value. Okay, that's an optional. Okay, if that worked, then this would be legitimate, and we don't need the we could just get float value here. Okay, so this is saying attempt the conversion. If it works, then that's the R value. Otherwise, and actually maybe I should switch this to the guard form. Guard, let this else something fall through, and okay, and this should complain. Yeah, there we go. Considering using a throw. Okay, so let's do a throw, and yeah, it's going to be this more or less. But let's take the error message from this test. Okay. And we'll do a build. It always starts trying to run those tests again. Okay, I gotta just do it this way. Run all tests. Okay, so we've covered both cases where the float converts successfully and where it fails to convert. And I think we're done with that. Okay, so data read tests. Read number fails when data is non-numeric. Okay. Let's commit. I'll make sure to run those tests again soon. Let's see. So make read throw error when data is non-numeric. All right, and let's see what we're saying here. Error of type mismatch. Yep. I started today's block already. Read number, data and read. Okay. Now, yeah, we want to do these quoted strings. So this line 20, we'd like to, if you have a comma or a space in there, you definitely need to quote it. So let's allow that. All right. So, and basically we're going to start, is there any lexical issues? Well, no, we already do quoted strings elsewhere. Is there a parser issue? Well, yes, there is. We don't handle that case yet. Okay, so data, let's look at data. Okay. We handle the case for unquoted string, but not quoted string. And actually, I'm almost wondering, we added this unquoted string idea. I don't know if I care. I mean, I guess well, no, I don't. We may not care. It may just be like we have a string token. Let's try that. Let's go back to our lexer. Okay, so the way it is now, it attempts to find unquoted strings in data statements. Okay, that's really the only context that allows it. And if it does, let's see, back up here at kind of the top level, it's really trying to do the unquoted string thing. And when it finds one, it returns unquoted string result. I want to say that should just be a string. How it got there, we don't care. Okay, so let's go back to parser. I think we don't care. Okay, so let's make the lexer return just string, just like it would for an actual string. Lexer tests. Well, let's find unquoted everywhere, and let's just turn those into quoted. Just into normal strings. So this becomes dot string. dot string. Unquoted string stops after colon. Okay. Here's unquoted string. Okay, these Lexer tests should fail. Okay, and it's basically the 4 or 5 tests we just touched, right? So 3. What else fails? Unquoted string is not equal to string, right? Okay, let's change the Lexer to just return string here. All right, let's run these tests again. Okay, so those are okay, but then anybody who does it quoted in here, we've got to worry about unquoted. They don't here. Okay, so the parser, well, if I run all my tests, I expect some parser failures. Okay, data retests, data with single number. Okay. Expected data value is not equal to data 99. Yeah, that's the same problem. Okay. Same thing here. We're getting expected data value because we're only accepting unquoted strings. Well, I think we should accept quoted strings. I mean, just strings. We don't care how they got there, quoted or not. All right, let's run all tests. I believe they should pass. All right. So let data statements contain quoted or unquoted strings. Okay. And then there was a little bit of funniness because you could, well, maybe we need a test for that. This is more of a confirmation test, but I should be able to read a number as a string. Okay, so this is more of a valid case. Let's put it before. Whoops. With numeric value can be read as string. Okay. Okay, so let's just simplify. Actually, it's an interpreter test. Data read tests, yeah. Okay. Read number fails. Anywhere in line. Okay. Read numbers, and then I guess this is very similar. Can read number as string. Okay, so read X dollar. The data is 10. Print X dollar. And we expect to see the string 10. No spacing before and after as numbers get. All right. And this should work is my assumption. Good. Okay. And let's go back to to-do. Oh. Data statements with quoted strings. Okay. This is going much faster than I thought it would. Guess we got over the hill. All right. Read array value. That's another test I think should just work. Did we already do that? No. Well, again, that test is going to be very similar. We're going to say can read into array cell. And if we read x sub 3, the data is 10, and we print x sub 3. All right. Good. Okay. Okay, confirm we can read numbers as strings and reading into array cells works. That's good. I guess we still have a couple things here. One is read beyond end of data terminates program. Okay, that's going to be a little more challenging, I think. Okay, check program results. If we, well, the easiest one, probably this, and I'm curious if it works. I think we just get nothing. We might get a new line. We're not defining any data statements. Okay, so we haven't tested that corner case, I don't think, anywhere else either. So let's do build and run. And this should fail. Yeah. Okay, so we're trying to just access data subindex. Well, data subindex is 0. Data index is 0. It starts out that way. But we have no entries at all in our data. So there's, we've definitely read past end of data. Let me change this though. How about read without any data? And I think we want to do a separate check on the other one. It should fall out, but that's okay. Okay, so the problem is if we can't find data sub index, then we should just terminate the program, and we have the end statement. We can see what happens there. Okay, it checks the stack and sets the done flag. Okay, let's make a method out of this. Fine. Try do end. Okay, and Okay, so in effect, I've done an extract method. All right, so we should get one test failure again, crashing here. Okay, let's comment out that test for the moment. Make sure everything else is happy with that end. Okay. Yeah. So now, if we can't just do this, we have to see if the data index. Well, whoops. I almost think we want to do it outside. Okay. Guard. We want to make sure that data index plus experts.count is less than data count. Okay, because we x 0 through n minus 1. So the most we'll do is add experts.count to it. Okay, so if we're at 0, we have two expressions. 0 plus 2, 2 less than count. Is that right? Golly. Guard this else something. The condition, well, this is a return. And a do end. Okay. Try do end. Oh, and I didn't call it above either, did I? Okay. All right. So if data index is 0 and the count is 2, 0 plus 2 is 2. That should have been okay. So I guess it's a less than or equal. All right. If it's index is 10, then 10 and 11 should be valid. 12 should not. Okay. And gotta find my end case again that I didn't actually do. Oh, I did. Okay, good. Those should pass. Did we put the test back? Yeah. Okay. And then we want to do one with data just to kind of confirm. 1020, line 20, read X. Can I do it in one line? Read X, that should be okay. Read Y, Z should blow up. Okay. Test read beyond end of data, terminates program. Okay, so we're checking that even if the second value is the one that would blow up, that we did detect that. Okay, and this should pass. So again, kind of a confirmatory test to make sure we've covered this case that I'm pretty sure we covered. Okay, but let's. Okay, so when read goes past end of data, program terminates. Okay. Let's see. So next, I think we're bound to restore. All right, so restore is so trivial. It's just resetting that data pointer. Okay, so I don't think this test will be too hard. Okay, so if we put in data 1020, read XY, restore, read MN. Actually, I'm just going to simplify this even more. Read Y and print Y. We're expecting 10. Okay, so it reads the 10. If we tried to read again, it blows up. And I think we've, yeah, I'm not worried we're going to mess that up. Okay, and then restore should reset it, reads the value, and does okay. All right, this test should fail. Oh, well, I don't parse it yet, so I'm going to get a parser error. Unexpected statement type or something like that, I think. Yeah. Okay. Let's save this test. Let's go back and do our parser. So easy to forget that you have to do that first. Okay. Test data. Yeah, I'm trying to be alphabetical-ish. For next, GOSUB return. I'm kind of all over the place though. On if stop. Well, we're before stop anyway. Function test restore. Okay, so our parse doesn't even know about it yet. Statement. Def and print read. We don't have a restore. All right. The interpreter is going to complain because it doesn't know what's there. What's this? Well, pretty sure it does. Okay, yeah, this one's not there. Restore, we're going to say throw. Okay, back to this test. Let's try and run it. Should build now. Okay, fails to do anything. And we've got data for ON-GOSUB, print read, return. Okay. Skip over the token. Result is dot restore. I don't need the word statement here either. Okay. That should work. Okay. Very good. Now our data read test restore. It won't get an unknown statement anymore. It'll just return, it'll terminate the program because we tried to read too far. Yeah, okay, well, we got our can't happen, but. If I just do a break here instead, do nothing, make sure we get the result I expect. Okay, so one failure. Empty string not equal to 10. Okay, yeah, so it just terminated. All right, and then instead of just a break, we just really need to restore data indexes back to 0. Okay, so data index is up here. Right, so we incremented it a ways, go back to 0. We don't need to reread the data or anything. Just do that. Okay. And that test should run. Okay. I don't think I see anything else in restore that needs much work. I mean, pretty much any time you call restore, it's going to reset your data pointer, and that'll be that. So make restore work in interpreter. Wow. Okay. We are done with restore. And we'll figure out what we're doing in a minute here. My inclination is not to go into this last statement, but maybe touch some of these other things. One in particular I wondered about. Well, okay, reading again. Can't run interpreter twice. Okay, there's something about resetting the variables that needs to happen if you run every time you run. Change the parser. We recognize this kind of high-level pattern of repetition. I'm thinking I might try a whole brand new parser. I might make a separate project out of that, building this. Take another whack at parser combinators. I wasn't happy with where we ended up last time. I found a nice article that I think may get us through it. Okay, this one though, can we fold float number to be value in expression? That feels like that would be interesting. So let's see if I can explain the issue. Probably in the grammar. I don't know if it's a good idea or not. So we're pushed, everything checked in. We can revert all this if I decide it's horrible. But in expression, you get numbers that are floats and you get strings. And really, they don't really get treated any differently. It's just the type checking numbers can participate in arithmetic and strings can't. So I'm wondering if I made value knows numbers and strings and other stuff. Let's see. It knows arrays. I don't know. Maybe this doesn't sound good. Like, how many places do we care? Maybe it's just not enough to matter. But it does know numbers. Let's see, where's the values? It could be undefined number, string, array, or a couple types of functions. I don't know. I guess we would be simplifying some of this, but then the type checking wouldn't work. We'd have to go in and explicitly type check stuff in our function calls. I don't think that's enough to matter. So, okay, let me mark that under good ideas that are actually stupid. I don't think it's going to help anything. There's kind of one place, two places where you distinguish them. Okay. Change parser. I I do want to look at things. Move token to the Lexer, share the Lexer. I don't know. One thing I'm kind of convinced the interpreter is just getting unwieldy. Okay. What were we up to? Over 1,200 lines? No, 800 lines. Excuse me. Part of that. Well, part of it, I know we've got other classes kicking around here and stuff like this. These defined functions. I don't really need them here. Location, I think, could be its own thing. Let's clean up this thing a bit. Okay, so I think one thing I want to do is I want to pull out location. Okay, so let's take some notes. Okay, so this is just refactoring. We want to, I want to pull location out to its own file. Interpreter error, I don't think I need to. Now type is very low level, value is a little higher level. So interpreter knows about value. Let's see if I can get the, value is defined for the interpreter level. So there's no way type would know it because type was defined back in the parser era. In parse, I think. Type, that back in the Lexer. Okay. So there's no way a function defined to cover the Lexer conditions is going to have the knowledge of value, which is more of an interpreter thing. Okay, so this extension is legit, but we can extract that too. Okay, so let's extract that too. I'll just say extract file. This is type plus default value. And I can say things consistently. Might be a good habit. Extract file location.swift. Let's drop these for now. I really want to get these predefined functions out. Okay, that would be a good thing. Okay. I'm kind of very sick of skimming past all these. Like, it's not the interpreter that's defining those per se. That's more of a definition. This is a little bit of a problem. We can't define at least one function until we get the interactor. But that's okay. All right, next location. Okay, then we get into the thing. Run loop. I don't know if... I'm trying to see what they're doing. Like there's... I mean, each of these is kind of standalone. Like they take store name interpreter. They also take this global location, well, not global, but field. Yeah, maybe something could be done there. I don't know. This is a little overwrought, maybe. Convert input. Okay. Well, that's similar to other code. Maybe we can fold some of that together. Okay. Yeah, there's something going on. It's not terrible. Okay. Let's tackle these then. Alrighty. So location should be the easiest one. And I would love to. There's still this thing about location's complicated because we get this notion of the partial lines. And I don't know. It would be nice to be able to fold that together with the go-to and all that. Okay, location.swift. All right, and run tests. Extract file location.swift, yes. Okay, and this extension. Commit that. All right, now this one's a little more complicated. Interpreter. I think maybe I can just extract this table. Let's make a file predefined. Just alphabetizing those. Interpreter kind of belongs on top. A file predefined values. I don't know. Okay, we'll need random. Okay, let's make sure this. Oops, more stuff going on. It will be declared in a type. Okay, so let's make a type. Class predefined. Let's pull these in there too. Last seed is up here. And I don't know, maybe this list can go down a little. Is that going to build? Okay. Now I know these two. Wait, $mid. Oh, mid function. Okay, who's calling that? Right, so these two functions can go over there as well. Predefined values. that's in here. Okay. The one that's still funny is that defer. We can't really define the tab function until later. Now I can pull this over maybe. All right, let's pull over build tab. I guess I'm gonna make we've got this equal predefined functions. Maybe this should be a function too. Let's try that. If you ask me for this with the interactor, I'm going to return you store. Well, I'm going to return you this. Okay. So I'm trying to push stuff over here, over to predefined. So I want this. I think I want to say globals equals predefined dot functions using interactor. Okay, and it's going to take this line. Results of tab, build tab, interactor, that's all fine. And then return result. And build tab. Is that still over here? Yes. right, and then we shouldn't need that anymore. Shouldn't need that anymore. Shouldn't need this. Should just be empty for starters. Then we're going to fill it in immediately in the constructor. I think if I take this off, I get an error. Yeah. Okay. You have to initialize the property before this deferred thing, but I can't assign it until I've got the other stuff together. I don't know. I think this will help us. Put it that way. All right. It should all work. Okay, so extract class or predefined functions. That's good. All right, this is... It's a little bit of a weird coupling to put all these functions together. I mean, the only thing that ties them together is they're all defined for you. But, you know, mid function versus sign. Yeah. Okay. Okay, I think we're good. All right, how's interpreter? Slightly smaller. Okay, so the program, the interactor, the location, the parse, and the globals. What else do we have? We got the flags. Oh, this awaiting input I'm okay with, but I think our resume is a little... let's change that name. Resume interpreter. Yeah, I think this is really... It's like... It's resume after input comes in or something. All right, so let's rename this. Continue after input. This one I'm going to call continue after stop. Okay. Okay, can we... I guess we're doing a parse. We have to know the parser. I wondered if we could push some of this out to another place. For each parse, for each statement... Yeah, so I'm wondering if I can map these. Okay, so instead of for each the statement, I'm going to do like we did before and do a dot. Well, put the dot down here. Dot map. Do something, and then on that do a for each. Okay, so if I map, I'm doing parse dot statement, so I'm mapping it to a statement. Cannot find part. Oh, this is $0. And this becomes statement. Okay, so take each number, map it to the corresponding statement. Which is like substatement or partial statement. And then if it equals statement, do the append. Okay, now this one, so I only want to do this I only want to do this if this case holds. Well, that's a filter. I think it's filter. Let's see. Swift filter. Well, let's try this. Okay. Yeah, filter, return all the ones where the condition is true. Okay, so let's see if we can do that. And I'm going to pull out another layer. No. Once again, I'm a little put off with my enums. I guess I would like to let maybe this is enough. This is complicated. Let me get the formatting fixed right first here. I should pay attention to the line number. Yeah, I don't know. This, okay. Take your program, sort it, map each line to the parse, then run through all the parses. For each parse, find the statements. Map each statement. I'm going to let it go. We may come back around. If I could filter this, I only want statements that are data statements. The ways I can see to do that don't end up being shorter though. Here it's nesting, but it's only one line to nest it. It's 119 is what counts. If I filtered it, I'd have to say, oh, if it's equals strings equals statement, return true, else return false. Maybe I could. Yeah, I couldn't return strings or not strings, I don't think. Okay, let's run tests and make sure it's okay and then close this. It's just one I think I may come back to again, but the loop for gather data. It feels slightly more complicated than I want. I mean, in a way, it would be nice. Program just knows strings, so it has no business knowing about parsers. But it would be nice if parser could just tell me these statements. I don't know. Okay, letting it go. What else we got on our list here? Well, I guess we can mention this refactoring. Improve gather data. Okay, interpreter. Can't run twice. Okay, let's deal with this. We did that part. Okay. Should it be layered? I think the answer is no. The thinking there, so what I was thinking was, oh, I could just have these predefined functions sitting there, and then how do I get rid of all the user-defined variables without affecting these predefined functions? Well, one way would be make this a more complicated data structure that the typical way is like has a pointer to a previous environment. Okay, so think of this as an environment, the mapping from variables to contents, and you could point to a previous one, so you would override values, and if you don't find it in the overridden section, you go back to the previous one and look there, and it may have a previous, and so on. We don't do our predefined functions that way, though, so I had thought maybe we did that. But instead we just make a copy and update it for the predefined and then restore it in the right context, because you can only go one deep. It's not a very recursive thing. Although here we are finding a use for the recursion, so I don't know. But if it were old BASIC, old Fortran don't really have that structuring kind of idea built in. Many other languages, especially if they allow recursion and stuff like that, have to do the environments in that kind of way where they point to previous environments. Well, not have to, but it's usually the efficient way. This, I think we can just do the same. We can just repeat the line in our interpreter, from our interpreter, the setup, this globals line. Okay, so I think we well, we haven't run this thing in a while. And I don't think we've even run this since you had the inputs. Oh, and it has that. Okay. We'll have to change it a little. Run. Okay, so we'll put this code in. And then let's change line 100. We'll make it print what are your width and length. Semicolon, and then the input H comma V. Okay, and we'll run. What are your values? 10, 12. Okay, yeah, that works. Okay, our input dealt with this, and then it prints the maze. Okay, but now if I hit run again, okay, it only got part way down. I don't know what's going on actually. I would have thought, what would I have thought? Well, I would have thought it would get down to maybe, well, I don't know. Yeah, like maybe 110. That trying to redimension it would cause problems. I don't think I'm really waiting for input. No. Something's screwy. Okay, so running it twice, and I don't know. Well, oops, sorry, interpreter. Okay, so the run gather data. Well, this program doesn't have data, so that's not really an issue. Let's go there. Oh, it does append to data. So there's something weird. Okay. I'm not sure the test for this is going to be a little crazy, but okay. We get a parse, we get a location, we start at the top. The thing I know is not right is the variables are starting out predefined, but why should that matter? All right. Well, I'm just going to experiment a little. I think. Why would the first line execute and not the rest? That's the weird thing. Oh, okay. I bet it stopped. Run loop. Yeah. Okay. We always execute the first line on a run, and then we stop for should run. Okay, so I think we can. Where's REPL? REPL test. REPL tests. Yeah, so run it, something like running test run resets flags. well, how about running twice works? Just start there. Um, Okay, so I want to do a run. Okay, let's just print 10, print 20. Okay, if you do a run, how about okay, so this thing, x should start out 0. At the end of the first run, x should be equal to 1 plus 0 plus 1 plus 2 is 3. Just x. If we do a run again, x should now be equal to 3. What I suspect will happen, I think it's going to run x equals 1, x equals 2, turn it into 3, come back here, run x plus 1 is 4, not execute the rest because the stop flag is wrong, and so it'll be 4 instead of 3. And if we don't reset the variables, then it's gonna show up to, it should really be, well, let's see. I think it should be 3. Okay, the first time it should run clean and get 3. Second time it should run clean and get 3. I think what's going to happen is it's going to run, get 3, run one more statement, get 4, and have the value 4. If we fix the stop flag, it'll have value 6, but it's still not 3. So I think this is probably going to fail that way. We'll get a 4. Okay, good. That sort of means my first intuition may be on track. All right, so if you say run, I think these should all be true. This should be restored. Okay, so we say var here, but we should execute the whole thing. Okay, and let's run this, and I think this time we'll get our 6. Okay. Right, because we haven't reset the environment. Okay. And I think gather data we need to we should reset this too. Okay, so we'll clear those. Data equals nothing. And then let's get our variables back to where they were. This. Okay, so run should reset state when it starts. Okay. And this basic, the thing I noticed here, this input, you're allowed to have an optional string semicolon before your variables, and it effectively prints that. I don't even know if we need to, well, for testing purposes, we don't need to care what the contents is. But let's add that to our input. Okay. Reset. No, let's drop that part. Data and flags. Okay. Grab the program. Oops. Just run it. Paste it in. Replace line 100. Input H, V. And run. Give it 10, 12. Okay, we get that. And then run again. Good. Oh. It didn't stop for input? Something's funny. Okay. Ugh. It's like we didn't clear the input buffer. Let's see. I totally forget how that part works. REPL. I guess the interactor. So what it appears to be is like the interactor has left input lying around. I thought the interpreter, when it did an input, consumed that. Let's find input. Do input. Well, we call getLine returns input. Okay, I guess we need to clear that input. Let me run again. Let's create a little sample. Let's do 10 input X, Y, 20 input MN, and run that. 1, 2. Right. Yeah. Okay. Clearly the interpreter. Well, I think get line should consume the line. All right, I don't know if we have an interactor test per se. It doesn't look like it. I don't think, well, yeah, let's put together a test for that. Okay. Whoops. Test get line clears input. Okay, we're pretty sure this doesn't happen. Whoops. Try that again. Okay. All right, and let's try our manual test again. Input X, 20. Okay. Good. So, make interactor clear input when it's read. Interactor. Okay, to do can. I guess this was a different thing, right? This was like interactor needs to consume input as it uses it. Okay, but we did both these. Trying to state these as facts, not conditionals, hypotheticals. Okay. Input string VW form ON-GOSUB. Parser errors, REPL scrolling, ugh. Token to Lexer, share the Lexer, that's possible. What should ASC do if given an empty string? That's probably easily answered. Let's do this. Okay. And I think we haven't taken a break yet. Let's take a 3-minute break. We'll come back, do this ASCII thing, which should be trivial. Input string will support that. And I don't know, maybe we'll start the ON-GOSUB just to see how that goes. We probably have time for that. Yeah. All right. So about 3 minutes. Hello, welcome back. All right. So this is just a leftover question for our string handling. Let's see, find predefined again. Okay. There's an ASC function. Okay. It converts a string to the character corresponding to its first letter. Okay, so it's there's CHR dollar. Basically, you can go back and forth between numbers and ASCII characters. Okay, so it's either a character or a string. The problem is if the string has no length, what are we going to return? Okay, we said here if it's nothing, just say it's a 0. That's probably acceptable. But I did dig up the documentation. So here's Commodore 64 has documentation on it. Returns number 0 to 55, 255 according to characters. If there are no characters, it should get an illegal quantity error. And they recommend you just attach a CHR dollar at the end so you always have a 0. That's kind of what we're doing. I think that's maybe acceptable. I think I will accept that. I also looked up, well, the old BASIC, the original BASIC, it doesn't have string operators, so there's no definition there. This one, 8K BASIC from like 76, it just doesn't give you enough information. I mean, this is very common to this, well, even across all of them, the definition is just not that tight. ASCII dollar, ask of X dollar returns ASCII value of first character in string. Well, no explanation at all of what it's going to do if it doesn't find one. Okay, so I think we'll leave that as just a divergence among the basics, including ours, and we'll just document it in our notes here. ASC of empty string returns 0, no error thrown. Okay. All right. And then in our quest to kind of wrap up the basic syntax, I think this occurs enough that we should probably support it. Once again, the original BASIC had no input statement at all, so we don't know what they think should happen. This BASIC, they forgot to document it here when they described all the statements. They put it in their chart at the end. Yes, we have input. We don't tell you anything about how it works. And this BASIC definitely has that format. Open. Too far. Okay. Input. Yes, they allow a prompt semicolon variable list. Okay, so let's do that. Anything? No. Okay. So input. We don't parse it. Actually, we don't even store it. Where's the parse? Input statement. It doesn't have a prompt, but we should add one, I think. Or maybe, no, I think maybe we should add it here. Okay, so let's add the string, and everybody's going to adjust themselves to deal with that. Let's see what happens. Okay, tests. Yeah, we certainly expect tests to complain. I thought the interpreter would complain. Yeah, that's the one I expected. Okay, let prompt, let expressions. Let's just assume we want to pass it along, and then do input. We'll take a prompt of type string and the expressions. Okay, and the parser case input result equals dot input. Okay. Let's make a method for this. All right, I'm just going to make an empty prompt for now. Do input. Okay. I don't want an out statement. I just want to return a throw, and I may return a statement. Go back. Input does not take. Okay, let's just make sure that builds. Oh. I don't need this anymore. Okay, no complaints in this file. Let's deal with the tests. Input. Okay, let's just assume you default to nothing if you don't specify one, which should be all these. Input. Oh, that goes outside the brackets. Okay, so we're kind of nudging it towards the shape we want, but we're not handling anything. All right, so input statements. Well, input with this, with that. Let's check with a prompt. And we can take a simple one. should see prompt. And okay, input with prompt. We've got the prompt in quotes, semicolon, $. We don't need the variables X and Y. Good. All right, this should fail. Okay, extra characters. At least one variable is required. Okay, I can accept that. So parser do input. All right, we read past the input statement. We have to look for the optional prompt. If token if let token no let prompt equals token. Okay. Get out of here and nested. If case dot string let prompt equals token. Okay. Can I say var? Okay, let's do it this way. Var prompt of type string equals nothing. If we have a string prompt, well, we're going to use it down here. We're going to set prompt equal contents. And then we need to do a next token to skip past the string. And then we need to require a semicolon. Doesn't that take an extra argument? Yeah, it takes a string. Okay. Let's go backwards. Semicolon required after prompt. And we need to check that. Okay. Sure. Okay. So if the prompt is there, it's going to use it. If not, it's empty string. This should just work. Let's see this test run. Okay, and then the error case is input with prompt requires semicolon. And this should fail with a TBD in the message. Not too badly. Okay, good. We'll take out that TBD. And again, this is kind of, I think of it as obligations. I had to write the require to get it to parse, but I then was obligated to test this part. And it should all work. Okay, so we parse allows prompt string on input statement. Okay. All right, and then interpreter. Interpreter tests. Okay, so where was data read? Oh no, input tests. Okay. But with prompt throws. Okay, so if we say 10 input quote prompt quote semicolon x and 20 print x, and the input is 42, then we're expecting to see well, I think we're going to see prompt question mark 42 new line and then the 42 printed. And what I think we'll actually see is no prompt in there. Well, that's interesting. What happened? Input prompt X line. Well, this probably should be trimmed. I don't know if that was it though. Yeah. Okay. Question 42, we did not get the prompt in place. Okay. So we print a question mark for the prompt, but we don't print the prompt itself. So let's just add the prompt in. And run those tests. Good. Okay, so input allows prompt. So we ready for ON-GOSUB? Scroll. Okay, I've got some refactoring to do on the tokenizer. Yeah, that may be useful. All right, but I think we're going to do ON-GOSUB. All right, let's see. I don't remember if this one has it. Yes. Okay. So there's an on-go-to statement where you give it basically an integer, and it decides which one to go to. Okay. If it's 1, it goes to the first, 2 is the second, 3 the third. The language, well, again, this one doesn't describe it, but there's also on-GOSUB. Same deal. Basically, everything's the same except it's a GOSUB instead of a go-to. They don't mention it up here, but that's okay. Let's see. And I think the reserved word aspect of it, we already support that reserved word because we do on-go-to, and we already have a GOSUB. So we certainly allow expressions, and we certainly have line numbers. So there's no lexer issues for this. It's another one that's a parse issue. Okay, so on-go-to, well, we need on-GOSUB that's very similar. Expression, list of line numbers. Yeah, and interpreter doesn't know what to do with it. Yes, I do. On-GOSUB. We have an expression and targets. Okay, and I think we're going to be so similar to this. We may just want to fold it together. Okay, but for now, let's just throw interpreter error that can't happen 0 on GOSUB TBD. Okay. Well, okay, it is the interpreter. This is so close. Yeah. Okay. We're back on the parser. So we've added this thing. We don't have a test for it yet. On go-to. Okay, let's test on GOSUB. Onto GOSUB. Well, it's not going to hurt it, but just to be sensible. All right, 2 should be 100, 200, 300. That should be an on-GOSUB. Okay, and this test should fail. The build shouldn't fail, but the test should fail. Okay, go-to is missing. Right, because we assume we're handling, we see an on and we think, oh, we must be doing a go-to. All right, but we're really doing it on GOSUB. Okay. Um, so on. All right. Here. Okay, let's make it switch on this. Switch on token. Case go sub and default. Okay. Well, somewhere we got to do this on go to. Well, we know the default is something like throw parse error dot error the token and one statement requires go to or go sub. That much is true. I guess we'll have to keep a state on this thing. Ugh. Save token of type token. We'll just save the go to go sub. If saved token is go to, we're going to do this. Okay. Should be green. How about the token? Oh. Maybe I should make this token type. Sorry, that goes away. And then we have to do a next token after them. I'm switching on the token, right? I'm mixing myself up. I guess we're using token type a lot. there was originally no distinction between token and token type, and now the token is the whole token. Ugh. All right. Now do I believe it'll pass? Maybe an error because of the on statement. I changed the error message. Yeah. Okay. And I think I want to change these other messages too. Let's just say on requires at least one line number. On requires line number after a comma. Okay. And okay, now let's see if we can clean this up a little bit. Okay. Let's say let's save token equal token. If token is not go to and token is not GOSUB, then we're going to do our error message. Okay, and this type should be token type. Yeah, good. Okay, token is not a go-to, it's not a GOSUB. We should get an error message. That should just pass. And then down at the bottom, save token is this or that. I think that's okay. And we ran all, so on-GOSUB supported by parser. Okay. We may have on tests down here in the interpreter. On go to tests. Let's rename this. Oh, if I do it up here, I'm better off. On tests. Well, I think we're going to need similar tests. Unfortunately, the programs are more complicated. On 2, okay, so we should stop here and We don't care about this. Well, maybe I do. Do I need this print? I don't know. But I really want an end statement, I guess. Either 20 or 30, and then a go return. Okay, so if 2, then it should come down to 30. It shouldn't print the 20. It should just print 30. Okay, I don't think I want this stopped. I don't think I need it. Not for this case where I can see it did its thing. Okay, so go to 20, 30, 20. We're either going to print 20, print and 30, or just 30. We expect just 30. Okay, this is on GOSUB. I will just make these on GOSUBs, and then we'll come check the. Okay. I'm really kind of trying to do them one at a time here. So let's see. Get tests marked. Okay. So on towning, go there. That should, well, that should be a GOSUB. GOSUB. Okay. I expect that one. All right. To give the, well, it's going to fail. GOSUB with negative value throws error. -1, GOSUB 2020 doesn't matter. It would be good to have a return. Well, it doesn't matter because it's never going to get there. Okay. On-GOSUB with 0 goes to next line. That's interesting. This one, if it came here, it should return. So that's probably worth putting in. GOSUB with too large value goes to next line. Same thing. Okay. All 4 of these tests will fail. If I counted right, 2, 3, 4. And I think it's a, whoa. What happened? Return called before GOSUB. Line 40. How did it get there? Oh, we did go to. Okay, did we? GOSUB. Wait a minute. Where'd my tests go? I think Xcode wasn't quite running the right tests. No, shows you what I know. It's acting like it did a go to. So did I get a condition backwards in my parser? If it's go to, do a go to. If it's GOSUB, do a GOSUB. Saved token. Saved token. Go to. right, let's look at those parser tests. Onto ON-GOSUB. All right. Let's get this over here. I guess we're gonna break on the color of this. Oh, we never called it. Yeah, we misspelled the call. Whew, okay. Let's try these again. They should get a TBD, not implemented thing. Okay, 4 failures. Can't happen. Yep. All right. ON-GOSUB. Now, I think this is the same body. Except I do GOSUB. Run those tests. Oh. Do go to can't fail, huh? Interesting. Okay. All right, those passed. Okay, now what can we do to make this more similar? Okay, so I think if we can just pass this function, let's make it file private function to on transfer. It's going to need some stuff. Okay. Let's take this whole body. Okay. And we'll want those arguments. Okay, expression and targets. If that, okay, and then we need another argument, which is and I don't even know how to write this thing, but I want this method. Well, let's do that. Subroutine location. So it's a location goes to void. The transfer method is location goes to nothing. Is it like this? Sure, put it in parentheses for me. I like it. Okay. So now I want to call transfer method instead of GOSUB. And this becomes, what do we call this? Do on transfer, expression targets, and do GOSUB. And this should pass. All right, and so this should be the same, except for do go to. Oh, I wonder if it'll like it if it doesn't throw. Let's hope that's compatible. Okay, and then let's inline these. On GOSUB, we will do, oh man. Do on transfer. Do on go to should be the same. Do go to. Okay. All right. Add support for on-GOSUB and refactor to a method that handles on-GOSUB or on-GOTO. All right. And you can kind of see why, like the original BASIC didn't have on-GOTO, but you can see why if you got on-GOTO, on-GOSUB is pretty cheap, right? Just one extra decoding, and there you go, you got it. All right. Well, we're at kind of a momentous place at this point. As far as I know, we've covered all the statements in here, and not all the statements on the C64 one, but most of them. We didn't do the input numbers. We didn't do stuff that was super tied to the C64 load, but we've got basically the functions, all the normal statements. We don't have open, we don't have close, but we didn't do peek and poke either. So I don't know what modes, well, let's just see. I know I've got some sample code we can pull around because the David All's classic book, like Basic Computer Games, is online, and he's encouraging people to do some stuff with it, or did open it up a little bit. And many of those are much closer to this subset on the left than C64. There are some that depend on that. And I've got another book that's like called Commodore 64 Games, I picked up somewhere along the line. We don't handle any of these kind of weird characters and stuff. We're not C64 specific. It's much more of a generic BASIC. On the other hand, we're basically done with it. Okay, so I think what I will do next time, I've got these leftover ideas. I think we will take another go at them. Some of this is cleanup. I, I I definitely want to experiment on the parser, but I think that might be a separate project. I think I think a different kind of parser and see how it goes would be interesting. Um, Another thing is like these expressions, they're so repetitive because you need one for each level of precedence, and I'd love to get past that. So we'll we'll do next time. We'll be focused on just kind of quality of life. So parser errors showing up better. See if we can figure out what's going on with this REPL scroll to bottom thing. Maybe some cleanup in the lexer, maybe some cleanup in the parser. And I think we'll call this project the basic interpreter. We'll call a wrap after tomorrow. And I've got other projects that I want to do, more refactoring kind of projects. I am working on a sort of a video course on refactoring, and I wanted to build this substantial project up to make it a target for refactoring. So, like changing the parser, minor changes, that's one thing, but switching over to a whole new parser type, I'd like to explore, like, how do you make a big change like that? That's a major design change from the parser's point of view. And I think that's kind of a separate project. I also have another one that's like convert to a compiler. Okay, so instead of an interpreter, run a compiler. And again, that's a pretty big sized refactoring I'd like to explore more deeply. But let's get these quality of life things going and pick up there tomorrow on addressing those things, see how that goes. And I guess yeah, that's it for today then. So tomorrow starts at 10 a.m. Eastern Time U.S. to 12:30 p.m. or 3 to 5:30 p.m. UTC. Otherwise, you get to adjust your time zone like I do for mine. And thanks for joining me today, and I hope I catch you tomorrow or in the future. Take care. Bye-bye.